These are the 0.2 notes for pre-calc. Today we're going to be solving quadratic equations. Quadratic equations are equations that have an x squared in them. Our previous lesson we were working on linear equations, so those just have an x and this is x squared. So there are 4 different ways to solve these equations. Example number 1, 2, 3, and 4 is all using square roots. So first example, we're just going to start by solving the equation as normal. Divide by 2. And then we are going to square root both sides in order to get rid of the exponent of 2. And when we square root both sides, it's important that we get a plus or minus sign and then our 2. And the reason that plus or minus is because when you square a number, whether it's positive or negative, it does always end up being positive. So let's just make a little note over here. We're always going to have 2 answers. And then down here, don't forget our plus minus sign. Example number 2, we're going to solve it a similar way. Subtract the 10. Then we need to get rid of the negative in front, so I'm going to divide by -1. And then it's time to square root both sides. Don't forget the plus or minus sign. Now 37, if you square root it, will get you a decimal. We would rather not have decimals for these type of problems, so we're just going to leave it as the square root of 37. The issue with these decimals is they tend to be irrational numbers, so they're just like these random long list of decimals, and then we end up having to round it. And if we round, then everybody rounds a little bit differently. So we'll just leave this in the form of the square root of 37. Examples 3 and 4 look similar, but there is a difference. Notice where the square, where the exponent is. On problem number 3, it's on the inside connected to the x, but on problem number 4, it's on the outside. And we're going to have to do that problem a little bit differently. Problem 3, though, we'll start by distributing. Then I'll combine the like terms. So I put those 2 together. Then I'll solve it by adding 23. Divide by 5. So notice we're getting the x squared alone again. And then square root. Put a plus or minus sign on. And the square root of 6 would give me a decimal, so I will just leave it as the square root of 6. All right, now problem number 4, I'm even going to switch colors because it's a little bit different here. Problem number 4, notice your square exponent on the outside. So let's make a little note over here. For example 4, don't distribute. And we can't distribute because the exponent technically needs to be done first. So instead of distributing the 4 in, we're going to divide the 4 out from both sides. You also can't distribute the square exponent into the x or the 7. So once we have this, then we'll square root both sides. We'll put our plus or minus 3. And then we have 1 step left. We still need to move the 7. Normally, we're done after we square root it. So this plus and minus 3, remember, does represent 2 answers, positive 3 and negative 3. So what I like to do is split it up into 2 separate equations, one as a positive and one is a negative. So I've got the positive 3 and a negative 3. And then that helps me solve it a little bit easier. Lots of mistakes happen if you don't split this step up. So highly recommend splitting that into 2 equations. All right, so that's solving using square roots. Most of those equations had an x squared and some numbers. Once we get down to problem 5 and 6, we actually have an x squared, an x term, as well as a number. So we're going to have to solve these a little bit differently. So example number 5, in order to factor something, we must set the equation equal to 0. Example 5 is already set for us to do that, so we'll go ahead and get started. What we need to do is think of numbers that multiply to make 15, but add together to make 8. We split up the x squared into an x and an x. And then the pair of numbers that multiplies to 15 adds to 8 would be 5 and 3. Both of those are going to be positive. Then I actually solve it. In order to do that, I take each equation, each little parenthesis, set it equal to 0, and solve. You could do this in your head if you'd like, or you can write the whole thing out like I'm doing. And here we get two separate answers again. For example, number 6, notice it's not equal to 0, so we're going to start by moving this 5 to the other side. And the 5 is a regular number, so we're going to line it up with the other regular number, the minus 19. If it had an x on it, we want to put it under the 2x. If it was 5x squared, bring it under the x squared. So always line up your like terms together. Now that we've set it equal to 0, we'll actually factor, looking for a pair of numbers that multiplies to negative 24, adds to negative 2. That's going to be 6 and 4. The 6 will have to be a negative. And then you can set each of those equal to 0 and solve. Here we go. All right, then on the back side, there's a different type of factoring. This is called borrow payback. This is if you have a number in front of the x squared. Right here, you can see there's a number in front of the x squared. We're going to do this a little bit differently. So first things first, we do have to set it equal to 0. So example 7 is ready to go. The first thing I'm going to do is something called borrow. And when I borrow, I'm actually going to be taking the first number in front of the x squared and multiplying it by the last number, by the constant. That's going to give me x squared plus 11x plus the 2 times 15 makes 30. So that's the borrow step. That's the borrow step. Then we're actually going to factor this just like we were doing on examples 5 and 6. So I'm going to find numbers that multiply to 30, add to 11. It's going to be 6 and 5, both positive. And now I'm about to do the payback. Remember, we borrowed the 2 over to the 15. Now we have to pay back the 2. So in order to pay back, we're going to do the opposite. We're going to divide by 2. First step, we multiplied by 2. Now we're going to divide by 2. If the number divides out, 6 divided by 2, into a whole number, 3, we're just going to go ahead and divide that. If it doesn't divide into a whole number, in other words, 5 divided by 2 would get us a decimal, we actually want to take the 2 and we're going to bring it right out in front of that x. So it's going to become 2x plus 5. So that's successfully borrowing and paying back. Then we would have to solve it just like we did before. Set them equal to 0 and solve the equations. So one of our answers is x equals negative 3. The other answer is negative 5 over 2. Or if you'd rather prefer that as a decimal, negative 2.5 is fine too. All right. So that's pretty much how you do 90% of those type of problems. However, there's another 10% that kind of fall into some special categories, and I want to make sure we go through those as well. So for problem number 8, notice this is not set up in order to be equal to 0. So we're going to start by moving everything to the left. So when I subtract 4x from both sides, I notice there is not another regular x number. I see an x squared, but I don't see an x. So I'm just going to kind of bring it over here. I don't want to line it up with a different number and accidentally add them together. Now I will bring my plus 7 over here and line it up with my other regular number, minus 10. Cancels, cancels, that gets me equals 0, which is what I want. Then I'm going to put these in order of biggest exponent first. So I'm going to bring down this 4x squared. That's this guy right here. Then I'm going to bring down the minus 4x. Then I'll combine the negative 10 and the 7 to make a minus 3. So I just kind of like rearrange those in the order that I wanted them. Now you're ready to start the borrow payback method. So we'll borrow to get the minus 12. Then we'll go ahead and factor it. Split up the x squared into x and x. And we're going to end up getting 6 and 2, a negative and a positive. And now we get to pay back. So when we pay back, we borrowed the 4, we're going to pay back a 4. Here's a special case. Here you want to reduce. Because you have fractions that could be reduced, you want to reduce it. So that ends up being 3 over 2 and 1 over 2. Then you can move the numbers in front. 2x minus 3, 2x plus 1. And we've successfully factored it. From there, you can solve to set each equal to 0. And so the end is very similar to the other problems we've done. I'm going to do this one a little bit shorter just by subtracting, adding 3 in my head, and then dividing it out so it looks like that. Again, I'll subtract 1 and just divide it. I'm just skipping a couple different steps because I'm running out of space. All right, the last method of solving is something called quadratic formula. Quadratic formula is more of a last resort. The problems get a little bit lengthy if you're not doing it at the right time. So let's start by writing out the quadratic formula. Quadratic formula looks like this. X equals negative b plus or minus b squared minus 4ac, that's all multiplication, and 2 times a. And again, this must also be set equal to 0. So the a, b, and c are numbers that are going to happen in front of either the x squared, the x, or the regular number by itself. So for problem 9, we're going to start by subtracting 6c squared and lining it up with its like terms. Okay, once we have it equal to 0, we can actually plug the numbers into the quadratic formula. So our a is going to be 2, b is going to be 11, and c is going to be 7. So we're going to do the negative of b, so negative 11, plus or minus. I'm always going to put this number in a parenthesis because when I square it, it's important that I include the negative, if there is one, with the square. I'm going to use a minus sign. 4, it's always a 4. A, which is 2, and C, which is 7. And then I'm going to do 2 times A. What I would recommend next is taking the calculator either on your Chromebook or on your desk at school and typing in what's underneath the square root bar. So we're going to take this entire part right here, all of this, and type it into the computer, in the calculator. So once you type that into the calculator, you would get an answer of 65. So what we do is we would get negative 11 plus or minus. We're going to leave the square root of 65 alone. We don't want to turn it into a decimal. And then just multiply the denominator 2 times 2 to make 4. And here's our final answers. Remember, that is technically 2 answers because you have that plus or minus sign, just like we did on the front side with our square roots. All right, example number 10. We'll move the 6v to the other side. And again, line it up with its like term, the other v. And I'm just going to put a 1 in front of here because I need a number for each letter. So I want to make sure we know that that's a 1. Right, and then we'll start plugging things in. So x equals negative b. Since my b is already a negative, that becomes a positive 1. So some people write it as a double negative 1 and then make it positive. It's up to you. And then b squared. This is really important. You got to have those parentheses right there. Minus 4 times a times c. All divided by 2 times a. Again, we're going to want to take the numbers underneath the square root here and plug them into our calculator. Include the negative and the inside the parentheses. So parentheses, negative 1, close the parentheses, squared. When we do that, we get an answer of 21. And then in the denominator, 2 times 1 is 2. And there's your final answer for that.